Good morning, students. Welcome to the class of TECHNO MATHICS. So today into the session, we will discuss for a question from electrostat where the resultant force need to be calculated. Okay. So three charges are given to you. Those three charges are placed at the vertex of an equilateral triangle. Okay. So if this is the equilateral triangle, right? If this is the equilateral triangle, okay, then the three charges are placed at this point, and this point, right? So let us say the three vertices are A, B and C respectively, right? And the charges which are placed over here are Q1, Q2 and Q3 respectively, right? Now, into this question, it has been said that the the amount of the charges Q1, Q2 and Q3 are 100 ESU, minus 100 ESU and 50 ESU, right? So this is 100 ESU electrostatic unit, right? 100 ESU. Q2 is minus 100 ESU and Q3 is nothing but 50 ESU, right? These three charges are given to you, right, which are placed at the vertex of an equilateral triangle, and the side of this equilateral triangle is 10 centimeter. All the sides are equal, 10 centimeter, 10 centimeter and 10 centimeter, right? Now we need to find the resultant force which is generating at charge C. Here, what is the resultant force? Okay, this is the question. The question is here that we need to calculate the resultant force at charge which is placed at C is what? That we need to calculate, right? Now, into this question, we know the equivalent force. We know the formula that the force acting due to the two charges by the law, that let us say the Q1 is exerting some force on the charge which is placed at C, and let us say that charge is F1, right? We know the formula F is Q1 Q2 by R square, right? Now Q1 and Q2 are the two charges, right? And it is inversely proportional to the distance between square of the distance between them. So if Q1 is exhibiting a force of F1 at Q3 here, right? Then we can say that F1 is, that is by Q1, F1 is equal to the two charges will be Q1 and Q3. So this will be acting into this direction, okay? into this direction, because this is in positive in nature and q3 is also positive in nature. So this will be repulsive, right? So f1 will be acting into this direction, f1, and the unit of this, the what is the what is the magnitude of this f1? That will be equal to q1 into q3, right? Here we have q3, so this will be equal to q1 into q3 by r square, and r square is nothing but 10 square, because it's an equilateral triangle and all the charges are placed at the vertex of the triangle. Now what is the unit of q1? What is the amount of q1? Q1 is 100 esu, right? So just put up the value of 100 esu over here, 100. And what is the value of q3? q3 is nothing but 50, and the distance between them is 10 square, that is 100. So you can see this 100 and this 100 is cancelled out, and we get the value of f1, that is 50. But since both of q1 and q3 are positive in sign, so the force which will be acting will be repulsive in nature. So we can say that f1, the force which is acting, is equal to 50 dyne, and it's repulsive. Why repulsive? Because both are positive, that's why it's shown away from q3, right? The force is acting like this here, in this direction, right? Similarly, f2 is a force, as here we have calculated f1 here. Similarly, f2 will be a force, f2 will be a force which will be exhibited by q2 and acting on q3, right? What is the value of f2? So here you can see the sign of f2 is q2 is minus 100 electrostatic unit, right? So here you can see minus 100 here, and this q3 is positive. So plus and minus both will attract. So the force will be acting towards this direction. F2 will be acting towards this direction, right? So we can say that this will be attractive in nature, because plus and minus. Now here F2, the force which is acted by Q2 on this Q3, Q2 on this Q3 is F2, and F1 is, here we have F1, F1 is the force acting by Q1 to Q3, and this will be repulsive in nature, because this is also plus 100, and this is also plus 50, right? So we have already calculated F1 equal to 50 dyne, which is repulsive in nature, right? So this is done. Let us calculate F2. F2 is Q2 Q3 1 by 4 pi epsilon 0. I am not writing it over here, that is a constant, okay? Q2 Q3 by R square, that is 10 square, right? Now here you can see the value of Q2 is minus 100. So the magnitude will be 100. Magnitude will be 100. I am taking it. Though minus is there, that way, that's why it will be attractive in nature, right? So 100 into Q3. What is Q3? Q3 is 50, right? So let me write minus first over here, divided by 100. So you can see this 100 and 100 will be cancelled out, and we get the value of F2 as 50 with a minus sign. So we can write that this F2 is attractive in nature, right? This is attractive in nature. Now, F1 acting here, F2 acting over here, right? Find the resultant force, right? The resultant force, you can see it will be acting somewhere over here, right? The resultant force will be acting somewhere over here in between F2 and F1, right? And this angle being an equilateral triangle, you can see this angle is nothing but 60 degree. In fact, all the angles are 60. If this is 60 and AC is a straight line, we can say that this angle is nothing but this angle is nothing but 120 degree, 120 degree, right? If this is 120 degree, let me shift a little. If this is 120 degree, what is the magnitude of force which will be acting over here, right? If this is F1, this is F2, the resultant force is given by this angle is 120 degree between F2 and F1, right? So we can write the equivalent force which is acting between F1 and F2, the magnitude will be given by F square is equal to F1 is equal to F1 square plus F2 square plus 2 F1 F2 cos theta, where theta is the angle between F1 and F2, right? Now, here you can see the magnitude is calculated over here, right? So the magnitude of F2 is 50, F1 is 50, though it's plus 50, it's minus 50. But a square will be 50 square and F2 will also be 50 square plus 2 into 50, that is the value of F1, 50 that is value of F2 into cos theta, and cos theta is nothing but cos 120 degree, this 120 degree acting between this F1 and F2, right? Now, what is cos 120 degree? 50 square is nothing but 2500, and this 50 square is nothing but 2500 plus 50 into 50, that is again 2500 into 2, that is 2 into 2500 into cos 120. Cos 120 can be written as cos 90 plus 30. So it will be lying into the second quadrant. So the value will be negative. the value will be negative because lying into the second quadrant, right? And what is cos will be converted into sine, and sine 30 will be 1 by 2, right? Cos 120 degree is minus 1 by 2. You understand it, right? I am assuming it. So here you can see 2 and 2 will be cancelled out, and here minus 2500 and plus 2500. So we have 2500 plus 2500 minus 2509. This is the force. Here you can see this 25 plus 2500 minus 2500 will be cancelled out, and we have the value of F square equal to 2500. And when you take the root into both the sides, you get the value of equivalent force, and that is equal to coming as 59. So this is the resultant force which is calculated, F equal to 59. Since F1 and F2 are equal in magnitude, you can see here 50 and 50. So therefore the resultant will be acting along the angle bisector, because this is equal in magnitude. So the resultant force will be acting in between this 120 degree, but this is basically at the angle bisector. So we can say, if this is the resultant force F, if this is the resultant force F, then we can say that yes, the force will be acting at an angle of 60 degree from one of the edges of the triangle, that is BC, right? I hope you students will understand the solution today. Thank you so much for watching, and be connected. Bye bye.